Morning. So today we've got another busy day ahead. I need to go to a couple of different projects. So we've installed heat pumps and cylinders. We've got a slightly different take on these ones. So we've got one that is with a Mixergy cylinder. The client's going to have some solar PV installed, so we've made sure that it's got the correct PV diverter and everything involved, so that they can start utilizing, harnessing some of the energy from the sun in order to charge their hot water during the particularly in the summer and spring months when there's more sunlight. I mean, it will work during the autumn and winter, but we have obviously a lot less in the way of sunlight hours. And then we've got a couple of the guys, so we've got Josh and Adam on another project just to do the pipe insulation work there to get everything buttoned up. Also, the client already has solar PV in place, so we just need to make sure that we fit the correct PV switch in order for the diverters to work. He's got a Mixergy Ecodan installed, solar PV diverter, so we just need to make sure all of that's working appropriately, is commissioned and ready to move on. And one of the other jobs on today with Josh and Alex, they're on a heat pump installation for a Valent heat pump, started yesterday. Run into a couple of hiccups there where we had the buffer that was needing to go into the loft, but the loft hatch was slightly on the tight side, so we just had to make some amendments in order to get the buffer up in there. And unfortunately, the building contractor didn't get the dimensions correct for the pad in which the heat pump needs to sit on, so that needed to be changed around. But guys are cracking on there today. If we've got time, we'll pop in and say hello and see how everything's progressing. I'll speak to you soon. There she is in all its glory, currently being protected because there's some rendering going on here at the moment, but it's all installed and ready to go. So we eventually got this all up and running. This was a culprit. So basically these RJ5s go on to the clamp that attaches, the CT clamp that attaches to the neutral on the incoming electrical supply for the property, and the other one goes into the solar PV diverter. But if you get one of these strands not connecting properly, then it just doesn't read, and you get a flashing red symbol come up on the side here. Now, as you can see, it's nicely flashing green, which means that we've got a full connection. So now, whenever there's excess PV energy, rather than going back to the grid, it will come back to here and it will start to heat the hot water on this system. So all good. Okay, great. That's the first one out of the way. So as I've just shown you, we've got the Ecodan, the Mitsubishi Ecodan air source heat pump. This house has been renovated, but to a very, very high standard. The amount of insulation that the contractors who actually owns the house as well has been exceptional. So, we really see that there's going to be a minimal heat loss of this property. They've really gone to town with draft proofing, etc. There's trickle vents in the windows, so there's plenty of ventilation in there to stop any moisture, etc. to build up. 16 panels on the solar side, so 16 solar PV panels up on the roof, which I think he said it was about 380 watts per panel, so it's something around about 6 kilowatt hour or 6 kilowatt peak load that's available. Obviously you're not going to get quite that much out of it unless you've got perfect sunshine and everything working 100% efficiently, but still a good annual yield available there. There's only going to be 2 people living in the house. We've got a PV diverter on the hot water cylinder, so any excess energy is going to go directly to the immersion of that system, which means that essentially, okay, they've made an investment putting in solar PV panels and PV diverter on the cylinder, etc. But from now on in, you know, it's going to be using, you know, the energy that is around, you know, from the sun, for example, and, you know, that's going to save them some money in the long term. The heat pump, because of the insulation levels, we've managed to set the temperature, the flow temperature for the heating system quite low. So they've put, you know, very large radiators in upstairs, underfloor heating down in the ground floor. So we set that to 45 degrees. You know, it's on a weather compensation, so that means that as the warmer it gets outside, then the flow temperature is going to start to dip, you know, to coincide and kind of get that equilibrium between the ambient temperature internally and what's going on externally. But there is very clear and easy opportunities to tweak up the temperature if necessary, or he may feel that, you know what, I would like to even try and save more energy. I'm plenty warm enough here, and you can tweak it down a couple of degrees. Every degree difference is going to make a difference to the efficiency. Next up, we're just going to go over to the other project that we're working on. It was one that we started last week. The guys are over there doing some insulation on the pipe work and stuff at the moment. So I'm just going to go and check on that, see what's going on. We've got a PV switch to install there. We are waiting for that to be delivered today. So hopefully by the time I get across, we'll see. And hopefully we can get that all connected and ready to go. So here we are in destination number 2. We're actually near Guildford. A little bit of a different placement on this one for the heat pump. As you can see, I am not on the ground, I'm up on a roof. And we were looking at different locations across or around the grounds of the property to see where would be best placed, and the client actually decided, you know what, there's not really a lot of room downstairs, so I would prefer to have it high up if we can. So we obviously had to get some lifting equipment to get it up above this garage. We've placed it on some wall mounts with anti-vibration pads involved as well, so that we don't get any resonance from any kind of vibration from the unit itself. As you can see on the back, we've got sufficient support there to hold the weight of this unit. The guys have been lagging or putting pipe insulation around to obviously prevent heat loss, and particularly on the outside it's very, very important, but we make sure that we're insulating throughout. We've got our rotary isolator switch here up on the wall, and our signal cable comes up from just down there and just below this window. Guys are working down there now. This is where the cylinder placement is. Now on this unit we've actually installed, rather than putting an antifreeze or glycol mixture in, which, looking at the prices at the moment for glycol antifreeze, has gone up exponentially over the last year. You know, they're putting the pricing down to the fact that oil prices have increased, and obviously like production and everything else and transportation gets very expensive. So what we've looked to do is find an alternative, because one, if the glycol is expensive, and I mean we were paying something around about £70 or something around about £65, £70 for a tub, which was 20 litres. Now we are looking at almost £200 a bottle. Not only that, but you have to size how much volume you're going to need, because you want to get, you know, kind of around about a 25% concentration in the water. So if you've got quite a large system, you could end up using a couple of bottles. It's quite labour intensive. You know, you need to set up a pumping station, place all your product in there, and then you've got to make sure it's all mixed perfectly throughout the system, and it can take some time. So, you know, we were looking at other alternatives, you know, what's going to be cost effective, both one for installation, and secondly, you know, to save you know, money on the fact that we're spending so much on glycol, because we have to transfer that cost over to the customer, and we want to make sure that they're looked after, and that, you know, we're being as efficient and cost effective as possible. So we fitted these Caleffi antifreeze valves, one on the flow, one on the return. Essentially what happens is we have a thermostat setting on the heat pump itself. So if it drops below, say from 4 degrees or below, then the heat pump would do a very, very light, small cycle just to keep a bit of residual heat into the pipework, and it would do a little cycle. If the heat pump was to fail, for instance, there was a power cut, the controls. Sorry, we've got a private airport quite close. Some multi-millionaires just flown over in their private jet. If we get to a situation where, I don't know, there's a power cut, something happens and the heat pump isn't in operation for any reason at all, or the thermostat fails or something, things can happen. They're mechanical items, by the way, so nothing's 100% certain throughout. But we would hope that we've got protection, or we need protection there to enable us to make sure that we don't have frozen pipework that's going to damage, the heat pump itself and the pipework outside. So these antifreeze valves, basically, if they reach below a certain temperature, they will open a spring-loaded operation inside. So as the temperature really, really decreases, it expands, opens up, and the water will trickle out just to take out any excess water and prevent any expansion. So this is what we fitted. We're going to see how these work out throughout the installations. I think it's probably the best bet and the best way to move forward, and it's probably going to be at least a minimum half the price of what we would pay to put glycol mixture in the system itself. So having a little catch up with the boys here, doing a grand job as usual for insulating all this pipework in here, and there is a lot of pipework to deal with, right? Adam's new kid on the block. Yeah. How's it feeling, bruv?
Oh, it's alright, to be fair. Yeah, it's well fun.
You've been doing, you love a bit of lagging, don't you?
Yeah, it's good fun.
We'll see how long that lasts. Josh loves it as well, don't you, Josh?
I do, mate. Get right in it.
So, as with the other project that was on just a little while ago, we've got a Mixergy cylinder here, and up there you'll see we've got a Mixergy Eddy Solar PV Diverter. So there's an array on the roof, which enables us then to be able to utilise some of the energy harnessed from the sun to produce some of the hot water here on this property. We're pretty much set up here. We are just waiting for a PV switch, but doesn't seem to have appeared or reared its head just yet, so we're hoping that's going to turn up soon. Then we can get everything linked up completely, and we'll be good to go. Just as I was about to give up and go, I thought, I can't wait here all afternoon waiting for it, and it turns up the PV switch is here, ladies and gentlemen. So it means that we can get this fitted, and then we can start getting the Eddy working with our cylinder and heat pump system. Sweet. Okay, so essentially, got a PV switch. We're going to mount that onto the cylinder. And then what we need to do is get that working so that essentially when the Eddy, which is the solar PV diverter, so for those that don't know, when the solar is generating electricity, if it's generating more than what's actually being used by the house, rather than it going back into through the grid and sending away and then getting some export money back in, which is between, I don't know, 3 to 5 pence per kilowatt hour, depending on who your suppliers are, we can actually utilise that energy, switch it back, pull it back in, and then charge the immersion heater on this cylinder itself. So all I've got to do is simply work out how we're going to get this wired in and fully functioning so that we can utilise that extra energy. I don't know about you guys out there, but I'm cracking on a bit in age, so I've got my trusty little kneel down mat for my old creaky knees. I'm sure I'm not the only person that needs to do that every once in a while. I'm not in my 20s anymore, so got to look after those knees. Okay, so back to this PV switch. So this is on a Mixergy cylinder. You can come with the cylinder, so it's got the PV switch already installed, or sometimes if you're adding in a PV diverter a bit later on, something that you can add. There's a fair amount of work that needs to be done, so you've got a few things that you just need to change across. So you've got the power supply comes in from the PV diverter itself, which is up there. Then we've got the controller, the Mixergy controller center that goes into this one. So you've got PV line, then you've got Mixergy line, which is basically the Mixergy controller, and then you've got immersion line, which comes directly from the immersion. So I mean, this has been slightly awkward, just purely on the position that we had to put the cylinder in, and with this control bin in front of this worktop. But essentially, you normally would have an outline coming up and going directly into this immersion thermostat. You remove that, take that Mixergy controller one back over to this one here, which is the second one, which is the second one in, as I've said. And then you've got your immersion, then you put a new wire into the immersion, coming back through, back down into here, and then you go into immersion line, immersion neutral, and obviously GND for your earthing. And then on here you've got, well, it's a bit difficult to see, but there is I don't know if you can see it down there, just in front, just down there, there's the stratification pump. That is usually connected in down the bottom. Unplug it from there, take it back into here, put it on one of these pump terminals just here, get the extension lead that comes with the kit, put that back, and then plug that back into the Mixergy controller, and that's it. That's all you have to do. He says after an hour, but that's all you need to do. And I'm just going to test this out and make sure it all works. Now it's time for the moment of truth. Let's test this baby. So what we'll do, select boost on one. That should become live. There we go, 230 volts. Perfect. Means it's doing its job. And we will cancel boost, yes please, and double check it again. Sorry, all fingers and thumbs at the moment. Test it again, and we shouldn't have any power here at all, and that we don't. There you go, nothing. Perfect, all working. Okay, so it was 2 heat pumps that we've commissioned today. As you've seen, there was 2 slightly different situations, scenarios there with the solar PV systems. Both had solar PV on the roofs, but the diverters were 2 different diverters. So we had one which was the Eddy, Mixergy Eddy, incorporating that into the Mixergy, and the other one was Mixergy's own PV diverter, both working alongside an air source heat pump. So you know, it's all good. That means that, you know, that's a couple more jobs ticked off the box, and we can you know, progress on for the rest of the week with other projects. I mean, I've just got probably one thing I would say with relation to Mixergy and the Mitsubishi air source heat pumps. And I think, you know, we're always about looking for smart, innovative technology and what works best with, you know, obviously looking at efficiencies and sustainability, etc. And I think that the Mixergy cylinder works well in many situations, many scenarios. However, I think that there's a slight niggle when it comes to working with the Mitsubishi air source heat pumps particularly, and the reason being is that the Mitsubishi software isn't as straightforward as such, and they've all got their own little nuances, their own little kind of, you know, special detail involved, which, I mean, predominantly, look, Mitsubishi want their heat pumps to work with their systems and work, you know, seamlessly. And I think when you're trying to introduce something that's very much, I'd say quite complicated in respect to, say, a standard hot water cylinder, there's a couple of systems that end up clashing. And I think where the Mitsubishi struggles the most with the Mixergy, it works perfectly well when you've got, say, PV systems installed and stuff, because you can use diverter valves to increase temperatures and stuff like that. But I think it's the 10% increment, the incrementation to try and get up to the 10%. And I think that probably Mixergy need to really look at, if it wants to work with Mitsubishi well, better than what it does, then, you know, we've got to think about how the two systems talk to each other. And I think it pretty much comes down to temperatures, hot water temperatures, thermostat positions, etc. And anyone who's worked on these systems will kind of understand what I'm talking about. So, you know, because what happens is when you're setting the Mitsubishi up for hot water and the kind of limitations of temperature, once it hits a certain temperature, it just kind of goes into a, I'm not going to, you know, it wants to shut it off. Now, what happens is, because the cylinder, the Mixergy cylinder, I'll go into this a bit more detail in another video, I won't bore everyone with it now, but because it heats from the top down, and you're producing a lot of heat at the bottom through the plate heat exchanger to send it back up to the top of the cylinder, you get a real mixture of temperatures fluctuating in and out. And I don't think the Mitsubishi control, or the control center basically doesn't really like those changes in temperatures too much, and it kind of messes with it. So what ends up happening as well, when you're looking to, say, I don't know, do a 50 or 60% fill up or heat generation in the cylinder, you end up losing a couple of degrees of heat. Working at 100% heat, so if you want to fully heat the cylinder at 100%, it works far better, and you'll reach those temperature, the temperature that you're really aiming to achieve. So, you know, 53 degrees or 52 degrees. But if you're looking to aim for those 52 degrees temperatures and with only 50 or 60% increments, then, or I say increments, setting, then you probably end up losing maybe 3 or 4 degrees of temperature. So you end up really having about 49, 48, and it diminishes quite quickly. So I think that's just one area that really needs to be looked at. Otherwise, the getting everything in sync isn't going to work. Sufficiently. Now, it will work well for some people, but for others it might not quite be satisfactory enough. So I just think there's a couple of points there that just need to be looked at, but we feel that we've settled and got a decent balance with the ones that we've installed, and we can't see that there's going to be any major issues there involved. But I think moving forward we're going to have to think about how we implement those. Anyway, thanks for watching. Please don't forget to like, share, leave a little comment, and of course subscribe to our channel. If you hit the bell notification, you'll see that we've got other when our other videos come available online. So we're just going to keep going. We're going to keep looking at different situations, different scenarios to which we face day to day. Not everything's as straightforward as you know, people may think, or we may make it look like when we're posting Instagram videos and photos up and stuff like that. You know, there's a lot that goes behind the scenes that really doesn't ever get shown. And I think it's probably, you know, more interesting for people to see the kind of challenges that we have to face. And if you're a homeowner and you're really looking to look at, you know, renewable technology as an option for your home, you know, then we want to be able to educate you and show you what is available, what is possible, and whether or not your home is suitable for those installations. But thanks for watching, and we'll see you on the next one.